Friends, welcome to my workplace at Ranaghat, West Bengal, India. This is a very hard cataract. We can call this cataract nigra. Let us observe this surgery. The surgery has been done today, and this is a totally unedited recording. This is the main incision on the posterior aspect of the limbus. This is a side port about 3 clock hours away on the left side, and this is another one same distance away on the right side. And now an air bubble is injected to fill up the anterior chamber. Beneath this air bubble, trypan blue dye is applied over the anterior capsule. The idea is to get some contrast while we do Capsulorhexis. And if the dye is applied underneath an air bubble, staining is very good in a very short time. Within 10 seconds, the staining is very nice. This is a bit of adrenaline. Now the dye is washed out. Pupil has dilated well, so that is an advantage. Zonule appears okay, but we can judge it better when we try to do rhexis. Visco 2% HPMC is injected into the anterior chamber, and it is applied over the cornea for better visibility. And now I take a Utrita forceps, scratch the anterior capsule, raise a tag, and hold this tag. Since this is a hard cataract, my aim is to do a rhexis of about 6 millimeter at least. In this case, I hope this rhexis is about 6.5 millimeter, and it is a very nice round rhexis. Now hydrodissection is done. Very small amounts of BSCs is applied at multiple points. The nucleus is tapped. And now as I keep irrigating, I try to rotate the nucleus, and the nucleus rotates very nicely. So the nucleus is now free from the capsule. HPMC is injected again to fill up the anterior chamber, and now is the time to chop this nucleus into fragments. And I am going to employ my technique, which I call Submarine Chop. The exposed part of the phaco needle is this much, and now the phaco needle goes bevel down. Some superficial cortical lens matter is removed. Can't remove much. And now I turn the handpiece, make the bevel up, and this exposed part of the phaco needle now goes into the substance of the nucleus, goes through the nucleus and moves through the substance of the nucleus like a submarine. As it reaches near the opposite equator, the chopper is used to make a crack. I rotate it 180 degree, sculpt once or twice, and then separate the nucleus completely into two heminuclei. Now each heminucleus is again subdivided. The tip goes through the substance of the heminucleus, and the heminucleus is divided into two large fragments. This is the other heminucleus. The tip goes through the substance of the nucleus, and it is chopped in this way. Now each nuclear fragment is tilted and emulsification is started from its apex. Ultrasonic energy used in this case is 90%, set at 90%. So when I press the foot switch full, I use 90% ultrasonic energy. This is the another fragment. Again I start emulsifying at the apex. Here I divided this piece into two smaller pieces, and it is done. So we have managed two fragments, and this is another fragment. So Phaco power used, as I said, is 90%, flow rate is 45 ml per minute, vacuum is 450 millimeter of mercury, and this is Pharos from Otley, Switzerland. And this is the last fragment, and I want to emulsify this again from the apex, but this fragment is small and it is floating freely, so it takes time to get the apex. Ultimately I got the apex, and I used ultrasonic energy to emulsify this last piece. At this time still I am in Phaco 2 mode, that is high vacuum, high flow mode, but from this point I decrease the vacuum, decrease the flow rate, decrease the vacuum to about 200, and flow rate is reduced to about 30, and thus it's taking time, but it becomes little safer to emulsify this last piece with decreased parameters. And see the wound. There is no wound burn. This is the beauty of Otley machines. In rock hard cataracts also, there is no wound burn. This is probably because of the very clever design of the titanium tip. The shaft is narrow and the end is wide. In this case I am using this bimanual irrigation aspiration for cortical cleanup, and it is done. And now is the time to implant the intraocular lens. I'm going to use a B cartridge, so I enlarge the wound to about 3 millimeter. And now here goes the lens. The leading haptic goes in the capsular bag, and the trailing haptic also, just by a push of the left hand instrument, goes into the capsular bag. Since the visco has not been used to implant the intraocular lens, going to take very less time to clean visco. And now is the time to close the side ports. This is a bit of moxie, and now BSS is used to hydrate the corneal stroma on either side of the stab incisions, paracentesis ons, and these stab incisions get closed. And now a final lavage of the anterior chamber. I always prefer to do this with a Simcoe because I can remove the visco from the corneal endothelium very nicely. See, there's a lot of visco sticking to the corneal endothelium. It has come out. The anterior chamber is very nicely formed. Few drops of moxie is applied over the cornea and the case is concluded. Thank you very much for your attention. Hope this video will help you in developing your surgical skills, give you some tips to manage hard cataracts in your practice. Be a great surgeon and serve your patients with love, respect, empathy, and great surgical competence.